warahmatullahi wabarakatuh. I am Abdul Karim Ladqani from the Department of Mechanical Engineering, and I hope all are good. Today we will talk about course Control System Engineering. Its main course in the Mechanical Engineering, and we will take a look for the introduction and the first chapter in this book. And this book it's Control System Engineering, six editions, and it's talk about let's say it's give an introduction and good idea for all the book, history of control system configuration, analysis and design objectives, the design process and computer aided design, and the control system engineering. So we will see what's this chapter have, and let's start with introduction. Chapter learning outcomes. After completing this chapter, uh, we will be able to define a control system and describe some applications, describe historical developments leading to modern day control theory, describe the basic features and configuration of control systems, describe control systems analysis and design objectives, and describe a control system design process and describe the benefit from studying control system. This is, I think, it's very important things you have to learn about it in the automatic control systems. After that, the control system definitions. What's the control system exactly? It's a control system consists of subsystems and processes or plants assembled for the purpose of obtaining a desired output with desired performance. So when I need a performance and I need specific output, I will use the control system to get the maximum efficiency, and I will get more benefit of this. So this is here. It's this is figure 1.1. It's give it to you a small maybe, or you will simplify description of a control system. So it's simply its input, and here it's input and the desired response. Then it will go to control. Then it will give you the output, the actual response. After that, you will see here this figure. I will come back to this figure with when I will get to it. Then you will get the advantages of control system. Yes, why I have used control system? It's power amplification, remote control, and convents and input form conventions for distributions. Control systems are also useful in the remote or dangerous location. For example, a remote controlled robot arm can be used to pick up material in the radioactive environment. So when I get the radioactive element, it's very benefit to use robot, and it's have a closed loop or control system. You can say it's like that. Then after that we will go to we will go to system configurations. Yes, this I will just stop with the important point. The system configuration. In this section, we discuss two major configurations of control system: open loop and closed loop. Yes, it's exactly have just two loops. It's open or closed. We can consider these configurations it's to be the internal architecture of the total system shown in figure 1.1. Finally, we show how a digital computer forms part of a control system configuration. So it's the main difference between open loop and closed loop. It's the feedback. Closed loop has feedback, but open loop it doesn't have feedback. So open loop system, it starts with a subsystem called an input transducer, which converts the form in the input to that used by the controller. The controller device processes as or a plant. The input is sometimes called the reference, while the output can be called the controlled variable. So when I give the input to the loop, I can call it reference, but the output it's controlled variable. Open loop system do not correct for disturbance and simply commanded by the input. For example, toasters are open loop system, as anyone with burnt toast can attest. The controlled variable outputs of toaster, it's the color of the toast. So when I have a heater of the toast, I don't need to close loop here. I have to just use open loop. So I will decrease the money I have to do it, or the tired of this. So it's opposite of closed loop. This is, we have here a block diagrams of control system. We can see the first one, it's open loop. It's just input reference, then controller, and we have here summing junction, process or plant. Note here we have disturbance 1 and disturbance 2. Then we have also summing junctions. Then we will get the output or controller variable. But in closed loop, we have the feedback here. So it will be same, but not enough, because I have to see here the set point or what I need exactly. So I will get the output or result with more accuracy. That's the main difference between closed loop and open loop. So analyzed and design objective. Transient response. Let's talk about this exactly, because it's very important things. Transient response, in the case of the elevator, let's say you have elevator and he have a slow transient response, make passengers impatient. So when somebody go to the elevator, he have to be comfortable and relaxed in the elevator, because if the elevator go something like a dangerous move or something, the passenger will be very scared and we have a big problem. So we adjust our parameters or design components to yield a desired transient response, our first analysis and design objective. Let's talk about transient response here. I will show you this figure, important figure about transient here. This is the elevator response, and this is the transient response. And when you are go to the elevator and the person when the elevator starts moving from the beginning, this is time and elevator location. It's like a move. Yeah, when the elevator starts move, he will move slowly here. slowly, 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 slowly. Then he will start increase the acceleration until he arrived here. So I can say here. So I can say this location here. It's the transient response. It's same like here. It's same. It's transient response. But here you can see it's like an it's like a line, you know? You can see here it's a line. So here it's not transient, but here and here it's a transient response. That's what we mean it by transient response, because it's the elevator, it's a closed loop. So he will take the feedback. He will take the feedback. It's continuous like this, you know, until he will reach the point he wants it. Then he will go straight. Then when he arrived to his goal, he have to also make a transient response also in the end, until he gets steady response and steady state error. We mean by steady state error, now when the elevator go up, he has to stop. It's right to the floor. So we don't need any space here between the elevator and the floor. So he will, when he stopped before 2 centimeter or after 2 centimeter, we will call that 2 centimeter steady state error. Yeah, that's all about elevator and transient. We will come back to our slides. Then steady state response, as we told you, we define steady state errors quantitatively, analyze a system's steady state error, and design corrective action to reduce the steady state error, our second analysis and design objective. Stability. Yes, it's stability. Its total response equal natural response plus forced response. For a control system to be useful, the natural response must be eventually approach zero, thus leaving only the forced response or to oscillate in the same system. We can say, let's continue this. Control system must be designed to be stable. That is, their natural response must descend to zero at time approached infinity or oscillate. In many systems, the transient response you see on time response plot can be directly related to the natural response. Thus, if the natural response descends to zero as time approaches infinity. Stability is our third analysis and design objective. Stability is our third analysis and design objective. Yes, it's very important things to take care about it. Other considerations. Something else we have to take care about it when we create automatic control system. The three main objectives of control systems analysis and design have already been enumerated. However, other important considerations must be taken into account. For example, factors affecting hardware selection, such as motor sizing to fulfill power requirements and choice of sensor for accuracy. Yes, as we say, we have to. The system will give us more accuracy when we work with a closed loop. Another considerations is robust design. System parameters considered constant during the design for transient response, steady state errors, and stability change over time when the actual system is built. Thus, the performance of the system also change over time and will be not consistent with your design. And performance is not linear, as we said in the elevator. In same cases, even in the same systems, changes in the parameter values can lead to small or large changes in performance, depending on the system's nominal operation point and the type design used. And as you know, it's all about you. What do you want? What do you want? It's the more important. He will decide you will design the automatic control, closed loop, or open loop, or anything you want, as you want. Then we have this case study, introduction to the case study. It's then this is the answer of this. How he will create the loop. It's a closed loop. Why? Because we have here the feedback. You can see this example. It's very easy. And after this examples, you have the design process. We have 6 steps to process design. Step 1: determine a physical system and specifications from requirements. First step, you have to know what do you want and the system you want, how you will write it. Second one, draw a functional block diagram. Then step 3, transform the physical system into a schematic. This is all 3. It's a chapter 1. And then you will go to chapter 2 and 3. That's he will talk you in the book. In the book, it's chapter 2 and 3, 13, chapter 5, 13. But it's the same step. Step 4, use the schematic to obtain a block diagram, signal flow diagram, or state space representations. Step 5, if multiple blocks, reduce the block diagram to the single block or closed loop system. And the last one, it's analyze and design the test to see that requirements and specification are met. And here we will take a look of this 6th step. He will go with it. And after that we have, I think it's all these points are most important. We'll take a summary for it because there's no time for that. All points we have. Control system analyze and design forces are 3 primary objectives: reducing the desired transient response, reducing steady state error, and achieving stability. Steady state response determines the accuracy of the control system. It governs how closely the output matches the desired response. The design of control system follows these steps as we just said about it. After that, in the next chapter, we will continue through the analysis and design sequences and learn how to use the schematic to obtain mathematical model. We have some review question, like name 3 applications for feedback control system, like elevator, like the car, the speed car, and like a heater of water. Yes, and it's 3 examples for open loop, like heater of toast or something. And that's all was the introduction, the first chapter in the book. And thank you very much for watching, and see you later, guys. I think here we are finished with that. Welcome anytime.